Title, same as last time, 6.5.2, adding and subtracting fractions, part 2. The difference this time is, if you may have noticed from your homework, well, all the example I gave you, the denominators were just numbers, right? You had numbers, integers, right, underneath. Guess what we're going to have now? You could have binomials.
Variables.
You can have variables. You can have trinomials. Yeah, that's what we're going to look at. Okay, so it gets a little more interesting. So last night's homework was pretty straightforward. Today, this is the type B type of question. You guys all ask me always, you know, which type. This is the kind of stuff you will see on your test. Okay, so for example, let's start with something pretty straightforward. 3 over y minus 6 minus 1 over y. Okay. Notice I have a binomial and a monomial, and I have variables, okay, underneath. So first of all, I don't like subtraction, so I like to change it to addition. So my first step is going to be doing that, changing it to addition. Then, of course, we have to find the LCD. If you want to add or subtract fractions, you have to have LCD. By the way, what's going to be the LCD for this fraction? 1 person, 2? 3, 4, 5, Anais? Nope. Y minus 6, the y will not go into y minus 6. So it's not going to work out. John? 2? Y minus 6 and y will go into 2? Where did you get 2 from?
What if y is like 17?
Okay, no, you don't know what y is. Yeah. Y squared minus? Yeah, don't multiply it out. Just tell me as a factor form. We want to leave it a factor. We'll explain this later. So it's y times what? Y times y is your LCD? Yeah, y times y minus 6 is your LCD. There you go. Okay, so if that's true, I would like all of you then to change it to addition and rewrite them with the LCD y times y minus 6. Okay? Go ahead, everybody try. By the way, this time the LCD happens to be the product of the denominators, right? You know why that happens? When does that happen? When does the LCD, when is the LCD product of the denominators? When?
Oh,
yes.
when they have like no common factor.
Yeah, when there's no common factor other than 1. Exactly right. Very good. Just like 1 over 2 and 1 over 3, right? If there's no common factor, you know that the LCD is 6, right? 2 times 3. Same idea. Does that make sense? Anyway. Anybody done with the second step? Changing into addition and then writing the LCD? Okay. Okay. Sure, tell me what to write. Okay.
3 over y times y minus 6 plus negative 1 over y times y.
No. What does the first fraction need so that you get y times y minus 6? That's the LCD. What do you need to multiply the denominator by?
Y minus 6.
No, you already have y minus 6, the first fraction. You need the other one. You need the... What? Uh-oh. Try. Look, right now the denominator is y minus 6, right?
Yeah.
We want to make sure, we want to rewrite this first fraction so that the denominator is y times y minus 6. What do I need to multiply the denominator by? Y. So if I'm going to multiply by y, I have to multiply also the numerator by y. You don't want to multiply this by y minus 6. Then you would have 2 of the y minus 6s. That's not the LCD. Do you guys get that?
Yeah.
Plus what? What does this 1 become if you change it to addition? Aaron?
Y minus 6.
Negative 1 y.
Negative 1, and then on the denominator, what do you multiply top and bottom by?
Y minus 6.
Okay, yeah. I think that's not the question I asked.
Wait. So
But you're fine. No, I asked what does that 1 become, Aaron, and then you said y minus 6. That 1 doesn't become y minus 6.
that's negative 1.
When you change it to addition, that's what I mean. Yeah, it will be y minus 6 once you multiply top and bottom by y minus 6. Okay, I understand. Okay, there, fine. Aaron, tell me what I get then. Let's simplify this. What does this whole thing become when you simplify?
You want the answer?
No, the third step.
Oh, okay. You do the negative 1. You
Okay.
distribute it.
Right.
Negative y.
Mhm. Yep. So You're right. When I distribute the negative 1, don't I get negative y plus 6, just like Aaron said? Yes? Okay, what's the answer?
Oh.
Yeah.
2y plus 6 over
Thank you. Yeah, 2y plus 6 over?
y squared.
Oh, you don't have to multiply the, okay, so leave a factor. Leave this factor. Yeah, you don't have to multiply you don't have to distribute these, okay? I'll explain to you why in a minute. So you get 2y plus 6 over y times y minus 6. And am I done? Actually, you are, but you know, I'm going to ask you to factor the numerator every time if you can. Could we factor the numerator if we, is this factorable? Yeah, Marilyn?
2y plus 6.
That's right. Marilyn is correct. You get 2 times y plus 3. Why do you think I want you to factor this? Leave a factor. What?
Oh, stop. No.
Is that good? I can make it this. Question? Oh, okay. Why do I want you to factor as much as you can the numerators and denominators? Yes.
Because when you factor it, you could like cancel.
That's exactly right. When you factor, if you don't factor, okay, you know, things may not. There may be some things that you could cancel still. You know what I mean? You have to simplify all the way. So here, this is what I wrote down. We want the final answer factor because we may be able to simplify further. Okay? This time we weren't able to, right? But that's okay. It's better to do it this way than not doing it, right? Because if you didn't factor, but some things happen to cancel, right? Your answer would not be simplified. You know what I mean? So for these fraction, I would like you to factor all the way, okay? Because if you had like factor of 2 on the denominator, right? It would have canceled out, you see? So you want to always factor. Any question?
We will.
Because we may be able to, simplify. Huh? Does that make sense? Yeah? Do you see what I'm talking about? Okay. Any question? Yes.
In the cloud thing,
Yeah.
it's after because
We may.
obey.
Any other question? Okay, may I go to example 2? Alright. Okay, go ahead guys. Try example 2 now. It says 2n over n cubed minus 5n squared plus 2 over n squared plus 5n. Well, actually, let's do this together. We have 2n over n cubed minus 5n squared plus 2 over n squared plus 5n. What's my first step? Yes.
Multiply by n.
No. Why would you want to multiply by n? Oh, so you want to multiply the second fraction by n over n? Would that give you the common denominator?
Yeah.
Not quite, no?
What?
It will not.
Minus.
Yeah, be careful. Okay, so that little, right? One of them is addition, the other is subtraction. So we have to look for the LCD. Yeah, if that was n squared minus 5n, the second fraction, I guess you could have done it that way. But really, to find the LCD, what should you do? Always do what? No, to find the LCD. Sorry. To find the LCD, you need to factor the denominator. How do I factor these denominators? First of all, n cubed minus 5n squared. Is there a way to factor that denominator?
Yes.
Raise your hand. How do I do this? Yes, sir. Derek. That's correct. I can factor out the common factor of n squared from the denominator. What about the other one? N squared plus 5n. Judy? Good. Everybody go ahead and write it down. Oh, wait.
I was right about that.
So you should all have 2n over n squared times n minus 5 plus 2 over n times n plus 5. Owen, did you? No, are they opposite of each other? No, unlike yesterday, they're not opposite of each other. This was positive n, that's positive n also. See? They're not opposite. Okay, be careful. So yeah, they're not total opposite. If they were, then yeah, you could factor out negative 1 and do the same thing as what we did last time. No, that won't work. By the way, who thinks then, now that I have factored the denominators, who thinks they know the LCD for this? Raise your hand. 2 people? 3? Lara? N squared times n minus 5 times n plus 5 is correct. Now, and you could have done it that way and you would get the right answer, but at the end you have to simplify a little bit more. This one though, you should always simplify.
Right there.
Could we simplify these fractions somehow? Yes. Oh.
Oh, wait.
Because there's, yes.
Can you cancel out an n?
Yes.
From the
First fraction.
yeah.
That's right. You see that there's n right here and there's n squared over here? Go ahead and cancel those out because it just makes it a little bit easier, your work, right? You don't have to carry. So go ahead, everybody do that and tell me what you get. No? Okay, so did you all get this? I get 2, right? Because n goes into n once. How many times does n go into n squared?
2 times.
No.
What, n?
How many times does n go into n squared? N times. That's why you n left.
Oh.
Okay, it's not 2n, it's n squared. Be careful. So now, it changes your LCD, doesn't it? It just makes it a little bit better. It makes it smaller. What's your LCD now? Who can tell me? Now that I have, see, always simplify. It just makes it easier. Alvin? That's right. N times n minus 5 times n plus 5 is your LCD. Okay? So go ahead and now rewrite these 2 fractions using this LCD. Okay? By the way, could I just use n minus 5 only? Because they look kind of similar. N plus 5, n minus 5. No, okay. Just because they look similar, you can't just, that'd be wrong. Okay, go ahead. Everybody try. Tell me what you get. Rewrite these 2 fractions using the LCD now. Go ahead. So we could add them, okay? Okay, all of you should have gotten this. Right? Multiply top and bottom by n plus 5, right? Because that's what it needs. Right? You have n and n minus 5 already. So you need to multiply top and bottom of the first fraction by n plus 5, which is the factor that we needed here. And then the other one n minus 5, because that's my LCD. And of course, you should distribute these 2 and 2 to the numerator. 2, right? n plus 5 times 2, and then 2 times n minus 5, because we want to add the numerators together, right? In order to add the numerators, you have to get rid of all these parentheses, right? You have to simplify. So how many people got this? 2n plus 10 over n times n minus 5 times n plus 5 plus 2n minus 10 over n times n minus 5 plus n plus 5. Raise your hand. Oh, not too many. Really? Okay, this is what you should have gotten. Huh? You left a factor? Okay, so for the numerators, before you add all these, you have to add the numerators, right? So numerators, at the very end, you leave a factor, not when you're trying to simplify. You know what I mean? At the very end, you factor. Okay. All right? Because, you want to gather your like term and so forth, right? You're adding all these, aren't you? So what does the numerator become? 4n, right? Is that my answer? 4n over this LCD? No. Why not? If you leave it that way, you would not get the right answer. Yes. Why not? So how do you simplify that? That's right. Just like before, you had a common factor of n on the numerator and the denominator. You could cross cancel n, so the answer should be 4 times n minus 5 times n plus 5. Yes, sir?
If you get all simplified, was all simplified, can you simplify the denominator and make n squared minus
Yes,
5?
if you know for sure that everything's simplified, you can multiply them out, but I'm not going to require you to do that because, things might cancel out and so forth. So it's fine for this fraction. I would like them to be factored, okay? The numerator and the denominator. Any other question? Do you think you could do one yourself?
Yeah.
Okay, all right. The last period couldn't do this one because example 3 was kind of hard. I'm sure you guys could do the.
We can do it.
Okay, you could do it. That's great. If not, that's okay. We'll go over it. But let's look at example 3 now.